right, so on number 28, we have an aquarium that has a length of 8 inches. So this down here, I'm sorry, x inches. This down here across the bottom is x. And it has square ends. So these sides, these 4 sides are all the same length because it's a square end aquarium. It says where the height and width are 20 less than twice the length. So I'm going to have to take twice the length, which was x, and subtract 20 from it. And that's how long each of these 4 sides is. All right, it says the volume is 5,000 cubic inches, and what are the dimensions of the aquarium? So I've got a volume, and I need to write an expression for my volume. And my volume is going to be the x times the length times the width, which would be 2 minus 20, 2x, whoops, sorry, 2x minus 20, and that's going to be squared because there are 2 of them. Now we know that that volume has to be equal to 5,000 cubic inches. So I want to find when is this expression for the volume equal to 5,000. So I need to go over to my calculator and I'm going to type in my x times 2x minus 20, and that quantity was squared. And I'm going to type in y2, 5,000, and I'm going to see where these 2 intersect. I need to set my view window. So I go into view window, and remembering that x is this height over here, or sorry, the width of the aquarium. So I'm going to start with the 0. And then how big do you think an aquarium would be? I don't know, it's not going to be more than like 3 feet maybe. I'm going to try 30 and see what happens if I do that. So I put in an x min of 0, an x max of 30, and then I can go to my zoom fit or my zoom auto, which is 0. And there's my picture. And I can see clearly where these 2 are going to cross, so my domain looks good enough. So I'm going to go to second calc, the intersect. I'm going to move close to where these 2 cross, and then I'm going to hit enter, enter, enter. For the first curve, I hit enter. For the second curve, I hit enter. And for the guess, I hit enter. So my intersection up here is at 18.271, and y is 5,000. So this 18.271, that would be x for my aquarium. And then to figure out what the other dimensions are, I need to do this 2x minus 20 by plugging in this value of 18.271 for x. When I do that, I'm going to go back to my regular home screen on my calculator. My calculator knows now that x was that 18.271 number, so I can type 2x minus 20, and that will give me the most accurate answer for the other 2 dimensions on my calculator. I'm going to go ahead and write this down while it's paused so you don't have to watch me write, and then we'll talk about the answer. Okay, so in my final answer, I need to give answer as a sentence. So I'm saying the aquarium has a length of my 18.271 inches. I make sure to put the units. And then when I went ahead and plugged that in for x, I got a width of 16.452 inches, and that's also the height as well. So notice I gave everything 3 places after the decimal. I gave units with all of my answers, and as far as work goes, I sketched this graph showing what was on my calculator screen. It's not a rocket scientist sketch, it's a loose little picture of what I had up there, but that way I can give you some partial credit if you don't have the correct answer. Okay, let's go over to the next one. Okay, number 29. The profit for a ski jacket manufacturer can be modeled by this function P of x. It's a cubic function, where P of x is the profit in millions of dollars, and x is the number of jackets produced in thousands. I always want to be careful when I have things that are measured in other than 1 unit. So the profit's in millions and the number of jackets are in thousands. For A, it says the manufacturer can only produce between 0 and 4,236 jackets. Graph P of x for this domain. Now notice in the domain here I'm at 4.26 because this was in thousands. So I just moved the decimal 3 places over. Label both axes with a scale and a variable. All right, so I'm going to graph this in my calculator. I've typed the function in y1, and now I need to set my window. So for my window, my x min is going to be 0. My x max is going to be the 4.236 number. If you just want to call that 4.3, that's probably fine. And then I'm going to do my zoom fit or zoom 0. And you can see I have this part of the cubic graph right there. I'm not really worried about this little part where it dips down below 0, but I want to sketch that over here on my paper. I did from 0 to 4.236, and that was x. My calculator's covering it up a little bit, but it says in thousands of jackets. And in my y-axis, that was the profit in millions of dollars. And if I want to figure out how high up I'm going on my calculator over here, I have two choices. I can go back to the window, and I can come down here and see my y max was about 12.2. So I just sort of ballparked that and called it 12. Later I might have to find the actual maximum on the graph using the calc button, but we'll see if that shows up. All right, so let's go on here for number B. It says find P of 1 and explain its real life meaning. Well, 1 is the x value. In this case, x is the number of jackets in thousands. So if we need to figure out what that equals, I'm going to go back to my graph. The easiest way for me to plug 1 into this function is to go to trace and just type 1. If I type 1, it tells me when x is 1, y is 4. So the x is 1 means 1,000 jackets. The y is 4 means $4 million because the y is profit in millions of dollars. So then I just wrote that out as a sentence. P of 1 means 1,000 jackets are produced. The profit is $4 million. Notice in my sentence, I use full words. I include units when necessary, in particular with this $4 million. All right, on part C, it says the company wants to make $5 million. How many jackets should they produce? Well, 5 million would be a y value. So what we're looking for up here in the picture is when my y is 5 million, or 5 as a y. So I'm going to type that in y equals, because that's the only place I can put a y in my calculator, and I'm going to graph it. You'll see when I do the graph that I hit 2 times, so I'm going to need to give both of those answers. I'm going to find second calc the intersection of those 2 curves. I'm going to move close to where it crosses, and I'm going to hit enter, enter, enter. So there's my first answer, 1.162. That was thousands of jackets. So 1,162 jackets. Now I'm going to find the other one, the intersect. Move over here. Sorry, that takes a while to move over. Close to where they cross, hit enter, enter, enter. And my second answer is 3.930, or 3,930 jackets. So I just need to write that as a sentence. Okay, so I wrote that down. For part D, it says explain the real life meaning of P, and then they've got the little -1 up here in the exponent, of 3 equals 0.28. Well, we need to know this little -1 up there in the exponent means the inverse of P, which is the opposite. So the input and the output have been switched. So the 3 is now really the profit. So that's $3 million. And the answer to this, the 0.827, that's how many thousands of jackets. So 827 jackets. So I just wrote that down as a sentence. All right, question E. How many jackets should the company produce to make a maximum profit? So let me go back to my graph over here. I'm going to go to my y equals, and I'm going to delete this 5 because I don't need that anymore. And I'm going to go back to my graph. I am looking for the maximum profit, so the high point on the graph. So I go to second, calculate the maximum, which is number 4. I need a left bound, so I'm going to go to the left of the peak. I want to get close, but not too close. I want to be sure I'm on the left. Then for the right bound, I need to go over to the right of the peak. Again, make sure you've gone to the right. And then for the guess, I want to get as close as I can to the middle and hit enter. So my maximum is 2.786, and my y is 12.208. So the question E asks how many jackets should they produce, and then question F asks what is the maximum profit. So the number of jackets is the X value in thousands, and the profit is the Y value in millions. So this is 2,786 jackets, and this Y value means the profit is $12.208 million. So I'm going to answer both question E and F with this 1 point. Okay, and the last one here, question G, is what is the range of P of X for the given domain? So the range is the possible Y values. If I'm looking over here at my picture, my lowest Y value is going to be 0, even though mine dipped below. Really, it should have stopped at 0 because that's where I cut it off at X is 4.236. And then it can go up to the maximum. So I just need to write that as an inequality. Since my original domain had equal to's in it, when I write my range, I'm going to have 0 is less than or equal to P for profit is less than or equal to my Y value of my maximum. So I wrote my answer as a sentence there. For the given domain, the range is, and I put it between P of X. And I also said in millions of dollars because whenever possible, I like to give units with my answers. Okay, on the last question here, we've got grain being stored in a silo that is shaped like a cylinder with a hemisphere dome. So we're going to have some sort of cylinder shape here. And then on the top of that cylinder, we're going to put a half circle, half sphere dome on there. So here's our volume. It's given by this formula. Based on the radius, it's 2/3 pi r cubed plus pi r squared h, where where r is the radius of the cylinder and h is the height of the cylinder. Now you should realize whatever the radius of the cylinder is, that's going to be the radius of the hemisphere on the top as well, right? So I gave you that formula so that you didn't have to figure it out. All right, on A, it says a farmer wants to design a silo whose cylindrical part has a height here of 20 feet. The radius r has not yet been decided, so he doesn't know how wide to make it. We're supposed to write a formula for a function v of r, giving the volume as a function of the radius. So all we're really going to do is we're going to take this 20 feet for the height, and we're going to plug it into this formula and then rewrite it. Okay, so I just wrote that as a sentence, and I did include on the end here that the volume would be in cubic feet, since we were dealing with measurements in feet here. All right, part B says, if the cylindrical part of the silo needs to be at least as tall as the dome, what is an acceptable domain for V of R? So if this part's 20 and that has to be at least as tall as the dome, then my radius would have to be between 0 and 20 feet also. So I wrote that out as an inequality. I put equal to's because theoretically I could have a 0 radius or a 20 radius. That's probably not going to be my most optimal situation, but they work. And then I included feet because the radius was measured in feet. Part C says draw a graph of the function v of r using an appropriate domain. Label both axes with a scale and variable. So again, this is our radius right here. And I want to put that I'm going to go between 0 and 20. And then my volume is coming up here, and that volume is going to be in cubic feet, and I didn't say it down here, but my radius was going to be in feet. I'm not sure how big my volume is going to be, so let's go ahead over to the calculator and put this in and see what happens. So clear that out. I have 2/3 to get a fraction. I hit math, I go over to number, and then I go up, and that n over d will provide a fraction for me. So I've got 2/3, and then I have a pi, and where's pi down here? Okay, and it was right here with the caret button. So I have 2/3 pi, and I'm going to use x to the 3rd power, move out of my exponent, plus pi, oops, sorry, 2nd pi, r squared, so x squared, and then that was times 20. I could have put the 20 in the front or not, it doesn't really matter. Okay, good. I'm going to set my window. I want my x min to 0. I want my x max to 20. And then I'm going to do a zoom 0, a zoom fit, to have it adjust for my volume. And there we go. It should make sense that the taller I make the silo part, the curved part on the top, the bigger the volume gets. So this one's not going to have a peak and come back down. It's just going to keep going up forever. We can't make the radius any bigger than the radius of the silo underneath though, and I've capped it out at 20. All right, so let's see here. We want to sketch this. So I want to copy this graph onto my paper here, and I added a y value of 42,000 right there for my maximum. I could get that a couple of ways. I can go to trace and I can type in that x is 20 and it will tell me my y value. Or I could jump over and look at the window. Either way, I can see I'm ballpark in the area of 42,000. And that's all I really need is an estimate for that one. All right, part D says, if the radius is chosen to be 6 feet, what will be the volume of the silo? So let me go back to my graph. And again, if I put in trace, I can type in any number I want to for x. So that's the easiest way to do this. Just type x equals 6, and you can see my volume is 2,714.336, and I'm going to want to write that down as cubic feet. Okay, for my final question, I have the farmer wants the silo to have a volume between 3,000 cubic feet and 3,500 cubic feet. What are the possible values for the radius? So I put two lines right here at 3,000 and at 3,500. And I'm going to have this range of volumes in between that will work. So I need to figure out where these two places are. So I'm going to do them one at a time. I'm going to go over here into Y2, and I'm going to put 3,000. And then when I graph, I'll see the line on there, and I can calculate the intersection. I want to move close to where they cross. Sorry, I can't see it real well where they are, but I can tell them close enough. I hit enter, enter, enter for all three parts. And there's my intersection at 6.283. And now I just need to repeat the process by going back and changing my 3,000 to a 3,500. Graph that and find the intersection. So it's nice if you don't put these in all at one time. If you do that, when you go to calculate, your calculator will get confused about which intersection you're looking for. So it's easiest to only have two curves in there at a time rather than putting both lines on like I did in my picture over here. So this second one is at 6.743. So I just have to write that as a sentence, and I have the radius should be between the 6.283 feet and the 6.743 feet. Again, making sure I use units, complete sentence, and if I want to show the work in my picture, then that's great too. All right, come to class with any questions that you have, and be ready for your test. Thanks.